Welcome students. Now in this video we are going to see the special welding processes. So in that, the first welding process we are going to see is that the electron beam welding. Okay, and this is the schematics of this electron beam welding. Okay, so basically in electron beam welding, the heat required for the fusion is obtained by the kinetic energy of the dense electron beam. Okay, so here in the beam which is consist of the electrons which are moving with very high velocity. Okay, so see here, this is the filament from where the electrons are going to emit. This is the controlled electrode, this is the ring shaped anode. These are the positioning diaphragm. So see here, so as what I said here, the EBM or electron beam welding process, the heat for the fusion is obtained by the kinetic energy of the dense electron beam, which is having the electrons which are traveling with very high velocity. So see here, the electrons are emitted from the cathode. This is from the cathode, and thereafter they are getting accelerated by this ring shaped anode. Okay, and for the focusing purpose we are having this electromagnetic focusing lenses, and finally this electron beam is getting impinging on the work surface. So here if we see, the accelerating voltage is ranging from 20 kilovolt to 200 kilovolt, and the current in milliamperes. Okay, so this is the accelerating voltage and the current which is used in the electron beam welding process. So see here, so of course the electrons which are emitted from the cathode getting accelerated by this ring shaped anode, then it is get focused by the magnetic lenses, and finally it impinges on the work surface. See, when the value of this accelerating voltage crosses the critical value, then what happened, this beam is getting penetrated into work surface, and in that condition, if the work is having relatively traverse movement with respect to this beam, then we can get the narrow bead of weld. What we are getting? The narrow. When this voltage crosses the critical value, this electron beam is getting penetrated into the workpiece or work surface, and in that condition, if the work is having the relative traverse movement, then we can get the narrow bead of weld. Okay, this is how actually the welding takes place in the electron beam welding process. Now see here, this process is basically not used for the materials which vaporizes more. So EBM is not suitable for the metals or materials which vaporizes more, and the materials which are producing the huge amount of gases or fumes during the melting, and the materials producing the huge or large amount of gases during melting. Okay, now see here, and one more important thing in this electron beam welding is that this entire setup is in the vacuum. So here the vacuum is around this vacuum, because process done in vacuum, which is around 10 to the power minus 3 mm of Hg. Okay, so if there is no any vacuum, so definitely weld is never exposed to the atmosphere. So the main advantage of the electron beam welding is that the materials having higher oxidizing or oxide forming tendencies like aluminum and magnesium, highly reactive materials, can be easily get welded. Okay, so this is the basic advantage, that if there is vacuum, of course the highly reactive materials can be easily welded. And please remember, whatever the this electron beam which is impinging on the electron beam weld, it is impinging on very narrow area. Okay, so this beam can be focusing up to the micro diameters. The diameter which is focused here by this electron beam onto the workpiece is in very little diameter, okay, in microns. So that is one more thing. So this is about electron beam welding process, suitable for highly reactive materials. Of course, aluminum and magnesium can be easily welded by this electron beam welding process. Okay, now the next special welding process we are going to have, that is laser beam welding. Okay, so see, if we look at this non-traditional machining, that is laser beam machining is there, electron beam machining is also there. So the process is quite same, only in machining process. So there is the mechanism of the EBM and LBM are what? There is a melting and vaporization of the material. Okay, so here in electron beam welding and laser beam welding, the mechanism, when we are limit this mechanism up to the melting of the workpiece only, we are not allowing the vaporization of the material, then it becomes what? The welding process. Okay, so here also, if you look at the laser beam welding process, the major advantage of laser beam welding is what? So here no vacuum is going to used. Okay, so no vacuum here, in EBM only vacuum is used. Now here, if you look at the laser beam machining, so there was the whatever the wavelength of the laser which are used for the or usable wavelength for the machining operation is from 0.4 to 0.6 micron. So laser beam welding, here in welding what we are going to have, so in this laser beam welding we have to select the wavelength of this laser such that it can produce the heating of the workpiece. So only melting is going to occur and vaporization will not going to occur. That is the thing. So it becomes the laser beam welding process. So in machining operation, usable wavelength is from 0.4 to 0.6 microns. Here in electron beam welding, the wavelength is used or selected is such that the wavelength will produce the heating of the workpiece only, so that only melting can take place but no vaporization will take place. So this becomes the laser welding process. And major advantage is what? Compared to EBM, no any vacuum is required. Again here, if you look at the weld area is very less, up to very few microns we are getting this diameter where the laser is going to focus on the workpiece. So of course low heat affected zone, okay, or very fine weld area we can have. Then see here, this laser beam welding can produce the power density as high as up to 10 to the power 7 watt per centimeter square. कितनी power density इसमें? Power density as high as 10 to the power 7 watt per centimeter square. So this is about laser beam welding. Okay.